Let's install and do a simple simulation for using LTspice. Now you can do a Google on LTspice, but I'll show you another way. If you go to cmosedu.com, now if you look, cmosedu.com, so it's a commercial website. We'll just hit that, cmosedu.com. not cmos.edu. We'll go down here and click on this LTspice link. We can follow the directions here of LTspice. It's powerful. It's LTspice Switcher CAD 3, powerful and easy use schematic capture program and Spice engine. It can be downloaded here, so let's click on here. Up pops a window and it says LTspice Switcher CAD 3. So we're going to click on that. We can register for a new account. We're going to say no thanks, just download the software. I'm going to save it to the desktop here, which it's saved as SWCAD 3. So we'll hit save, and that'll take 15 seconds or so. I'm going to go ahead and close this window and go back over here. And if you look, there is in this this contents of this zip file here, there's literally hundreds of examples ranging from simple RC circuits to transistor level op amps, etc. So you can see the LT user's manual here, and then here I'm putting the videos in on using LTspice. So let's go ahead and close this. We'll not save this for the moment. Let's run our switcher CAD. So we'll hit run, we accept, install now, and it's starting to run now. So the point of the previous discussion pointing out those zip file was you can download that, especially if you're new to Spice. Go to chapter 1 and there's every type of analysis from a DC simulation to transient simulations using RC circuits, transfer functions, simulations, etc. So LTspice Switcher CAD 3 has been successfully installed. So there it is. We're going to go ahead and close it. I'm going to go ahead and get rid of my executable. And then there's the Switcher CAD 3. So I'm going to start it, maximize it. Now I want to make just a simple little circuit. So I'm going to go to File, New Schematic. And you know what? I don't like the gray background, so I'm going to go ahead and change that. So I'm going to go to Tools, Color Preferences. Then I've got the waveform window, the schematic window. Let's just go ahead and click on the background, or we could set it right here, and set the color of the background to white so it shows up better in these tutorials. Say OK. Now I want to see the grid, and I don't need to show the grid, but I will. Control G. There's my grid. Now I'm going to make a simple resistive divider, and I'm going to do what's called a dot operating point analysis, which is no plotting. It just says what is the DC operating point of this circuit. So first thing I'm going to do is I'm going to put a resistor down, put a resistor here, and drop another resistor down. I'll press escape to get out of this placing mode. Now I want to rotate this resistor, so what I'm going to do is I'm going to go over here. Now this is move, and this right here is drag. Now let's just click the move. We'll see what those do in a moment. So I've got this going, and I want to rotate it. Alright, so there's actually I've got this on a low resolution screen, but there's actually additional icons we can't see over here. So what we're going to do, we're going to go up here and we're going to look at the various different things. We've got drag, move, duplicate, delete, place bus, label net, rotate. Oh, that's just Control R. Okay, well, if I had all my icons up here, I could press the icon, but I don't. So, and notice I just hit fit to screen. So I'm going to type Control R. And so let me rotate it a couple more times. Control R and then place it. Now I'm going to connect wires up. So I collect this wire, then I click here, go over, click here. I'm going to go put a ground in here and a ground in here. I'm going to collect the wire there. Then I'm going to go to these components, and let me see. Can I put, oh, there's components just by pressing F2. So I'll go to components, and I'm in the basic library of symbols. And the first thing I'm going to put, I've got all these things that come from linear that I can use, but I want to keep my sim simple because I'm new to Spice. I'm going to go down and click voltage. Say OK. Put this in. Right click to get out of the mode or escape. Then wire this up the rest of the way. Then hit fit or escape, get out of the mode, and we're fitted already. We can zoom in, we can fit, we can zoom around basic size, etc. You know, I noticed that this ground symbol here isn't at the same height as this one, so I can do one of two things. If I move this component, watch what happens. If I drag through here, it moves it. So I can hit escape or control Z. If I can drag it though, if I drag it, then that's what happens. So I'm going to drag it up so it remains connected. Let's see. If I go back now and I hit edit and I hit undo or F9, if I go back and let's say I hit move, and let's say I move it up like this, well, now that's not the right, it's at the right height, but it's not making the right connection. So I can go over here and see what happens if I click that, click that. Oh, I can hit F times, and oops, let's get out of the mode, escape, F, hit F. That's not undo. Undo, I'm on a laptop, so the function keys don't work all the time. Alright, so let's go back and drag it up. Alright, so we're almost ready to do a sim. We got a couple more things to do. First thing we can do is right click on the component and put the value for the R. Well, I right clicked on the value, I can right click here and I can put the value for R. So let's just put 1K for 1 kilo ohm. Then here I'm going to put 1K. And let's go ahead and just put this as 1 volt. You can use 1 or 1 volt. You know, I don't like the way these are arranged, so I'm going to change them. And now notice if I can use the drag if it's not connected to anything. Just drag these over. And you know, I'm going to right click on that name and I'm going to call that name VN, just because I like nice looking schematics with the inputs. Okay, so I'm ready to do a simulation, but I need to tell LTspice what kind of simulation I want to do. So I'm going to go add simulation, and again I would normally use a key that's over here that's not showing on this screen, but I'm going to go to, let's see, what can I do here? I can do a spice directive .op or S, spice analysis. Well, I'm going to do a spice directive, and I'm just going to type OP for operating point. All Spice commands that tell how to do a simulation start with a period. Okay, so I'm ready to simulate this circuit. Before I do anything, I'm going to save it. So I'll do a file, save as. Let's put it in, notice it's got an ASC back. Let's call it LTspice. Yeah, let's just call it Sim1. Yeah, let's call it CMOS EDU just to be descriptive. CMOS EDU Sim1, and we'll just put it in this directory, which is under Program Files LTC Switcher CAD 3. Okay, so now I'm ready to, before I do anything, I want to view the Netlist. So I've got my Spice Netlist, and I look at it. In Spice, any line that starts with an asterisk is a comment line. One other important thing to remember, especially when you get more advanced, is the first line in a Spice Netlist is always ignored. So this is the title line. It's saying, hey, this is the file we're going to. Now we have a resistor R1 from some node N002 to 0 of 1K. So R1 goes from some node N002 to ground. 0 is always ground in Spice, and it's 1K. I've got R2 going from node N001 to N002, and it's 1K. And then I got Vn going from node N001 to 0 of 1 volt. So notice this node is a 0 node, this node is a 0 node, indicating that both are ground. 0 and ground is always ground in Spice. Now if you ever write, of course LTspice will simulate Netlist that you write by hand as well. And if you have a Netlist where you've put O instead of 0 for ground, it could cause you pain. Okay, so we're going to run the simulation, and then what we're going to see is if there's any errors or anything like that. So let's hit run. And it pops up and says, here's our operating point. Node 002 is at half a volt. Node 001 is at 1 volt. So obviously that's correct. And then our current is half a milliamp, or 1 volt divided by 2K. So I close this, and this just tells me I've got half a millivolt. Now notice, we'll do this often here, notice that my current flowing in Vn is minus half a milliamp, where the current flowing in R1 and R2 is plus half a milliamp. You need to remember this because Spice defines positive current flow as from the plus node to the minus node. So when it says what is the current flowing in this voltage source, it's minus 1/2 milliamp, meaning the current's actually flowing like this. Now let's modify our netlist. Actually, let's go up here and view Spice error log. This tells us how long the simulation took, that it was successful, and some other Spice information. Let's see. We'll cover some of this other stuff. Well, let's ask the question, what happens if I'm using the cut? What if I put the ground right here? And then I come up here and I resimulate. What will happen? Let's view our netlist. It's the exact same netlist. I resim. I run. Come down here and I get exact same results. So I was lazy before by putting the ground here and here. Now I put the ground in the middle and completed the circuital or circuit route of the current flow. We've got our pressure here pushing a current flowing in this direction, or our electrons moving in the opposite direction. Let's do one more thing before we quit with this simple sim. Let's go and define these node names, because you know what, when I'm probing, I don't know node 001 is this one and N002 is this one. So I'm going to go up here, I'm going to click on this label net, and I'm going to call this node Vout. Then I'm going to come up and call the other node Vn. And note, even though the source is called Vn, the node here was node N002. So if I view my netlist now, instead of having the output being called N001, or R1 being connected between N001 and ground, now it's connected between a node name of Vout and ground. So let's go ahead and run this sim. Now when I run, I get, hey, the output's half a volt, the input's 1 volt, and I've got current flowing in R1 and R2 of half a milliamp, and a current flowing in Vn of half a milliamp, but I know it's minus because Spice defines positive current flow as from plus to minus, and my current's actually flowing in the opposite direction. Okay, so that's good enough for now. Let's save this netlist and quit.